All right, let's get right into it. You want to become an AI engineer in 2025. It's probably one of the most exciting roles in all of tech, but let's be honest, the path to get there can seem super confusing. Well, today we're going to cut through all that noise with a clear, practical roadmap. Let's do this. So, first things first, let's get one thing straight. A lot of people hear AI and their brain immediately jumps to data scientist. But are they really the same thing? Not at all. A data scientist might build a model to find some insights in a spreadsheet, but an AI engineer, they're playing a totally different game. And here's the absolute key. An AI engineer is a hybrid. It's a role that lives right at the intersection of hardcore software engineering, modern machine learning, and really robust systems design. See, they don't just analyze data. They build, they deploy, and they scale intelligent software products that might serve millions of users. It's all about production, not just prediction. To get there, we need a map, right? Before we even think about starting the climb, we have to see the whole mountain. This roadmap is designed to give you that bird's eye view, that high-level picture of every single area you're going to need to master. So here they are, the 6 pillars that are going to support your entire journey. We're going to start with the non-negotiable foundations, math and core ML. Then we'll blast off to the cutting edge with LLMs and generative AI. And finally, we'll cover the really critical stuff for putting it all into the real world, the production stack, which brings together MLOps, data engineering, and responsible AI. Let's start digging into those first 2 pillars. You just can't build a skyscraper on a weak foundation. And for an AI engineer, that foundation is a solid, practical understanding of some key math concepts and the fundamentals of classical machine learning. Now, don't panic. You do not need a PhD in mathematics, but you do need to speak the language. Linear algebra is crucial because everything in AI, from images to words, gets represented as vectors. Calculus? That's the engine of learning itself through something called gradient descent. Probability helps us handle all the uncertainty in the world. And optimization is literally how we train models to find the best possible solution. So how do you learn this without getting bogged down? Here's a proven path. Start with 3 Blue 1 Brown series on linear algebra. Seriously, it's the best resource out there for building intuition. Then, check out Harvard's Stat 110 lectures on YouTube for probability. Finally, just skim the classic Convex optimization book by Boyd and Vandenberg to get the core ideas behind model training. Okay, with the math in place, we can turn to core ML. These are the timeless principles. You've got to understand the difference between learning with labels and learning without them. You absolutely must master the train validation test split to evaluate your models honestly. And you need to really deeply understand that fundamental tension between a model that's too simple, that's high bias, and one that's way too complex, that's high variance. So what's a concrete goal here? Well, a fantastic test of your understanding is to try and implement a simple logistic regression model from scratch, using only a library like NumPy. If you can pull that off, it means you truly get how data, math, and learning all click together. All right, now we move from the foundations to the frontier. This is what most people think of when they hear AI in 2025. Large language models and the incredible, mind-bending world of generative AI. This is where the magic is. It's easy to think of these LLMs as black box magic, but they're not. They're a pipeline. First, we tokenize text. That's just turning words into numbers the model can work with. Then, that data flows into the transformer architecture. That's the powerful engine behind models like GPT. From there, you have a strategic choice. Do you fine-tune the model or use a technique called RAG? And finally, and this is the most important part, you have to rigorously evaluate your output to make sure it's actually any good. And that brings us to probably one of the most important concepts for a modern AI engineer, RAG. Retrieval-augmented generation is the absolute key to building reliable AI applications today. See, instead of fine-tuning a model on your entire knowledge base, which is super slow and expensive, RAG first goes out and retrieves relevant factual documents and then feeds them to the model as context. This is exactly why it's dominating enterprise AI. It's cheaper, it gives you control over the data source, and it makes the model's answers verifiable. To master all of this, you need the best resources. Start with the Hugging Face course. It's a fantastic practical introduction. For a deeper, more academic dive, Stanford's CS224N is the gold standard. And if you really want to understand how these systems are built from the ground up, Andrej Karpathy's legendary Zero to Hero YouTube series is an absolute must-watch. And for practical tips and tricks, the OpenAI Cookbook is an invaluable reference. Here is your project goal for this section. If you can build a simple app that takes a PDF, indexes its content, and then lets a user ask questions that are answered directly from that document, you've just demonstrated a powerful, practical, and highly marketable skill in generative AI. Okay, so you can build a model. That's fantastic. But an AI engineer's job has only just begun. Now we get into the production phase, which covers the final 3 pillars of our roadmap: data engineering, MLOps, and responsible AI. This is the stack that turns a cool prototype into a reliable, scalable product. First up, data engineering. Your model is totally useless if it's starved of high-quality data. In the real world, you're going to work with 2 main types of data systems. You've got OLTP systems that power live applications. Think fast reads and writes for your app's user database. And then you have OLAP systems, which are for huge scale analysis, like massive data warehouses. A great AI engineer is comfortable building pipelines that pull clean, timely data from both of these to feed their models. Next up is MLOps, which is basically applying the principles of DevOps to machine learning. This is what separates a hobby project from a professional system. It means versioning your data and your models. It means building CI/CD pipelines to automate testing and deployment. It's packaging your services in containers like Docker for consistency. It's monitoring everything in production with alerts for when things go wrong. And it's safely rolling out new versions with A/B tests. It's a whole discipline of rigor and automation. And as you're deploying and versioning all these models, a crucial piece of responsible engineering is documenting them with something called a model card. The best way to think about it is like a nutrition label for your AI. It transparently shows what the model is, how it was trained, what its limitations are, and how it performs. And trust me, this isn't just a nice-to-have anymore. It's becoming a standard for professional, trustworthy AI engineering. Wow, we've covered a huge amount of ground. We have our map, and we've explored every single region. Now for the most important part, turning all of this knowledge into a concrete, actionable plan that you can actually follow. The absolute best way to learn is by building. So this project ladder gives you a really clear progression. You can start with low-tier projects just to get comfortable, then move up to the mid-tier, where you build your own RAG chatbot or fine-tune a model. The high-tier projects, they involve building complex multi-service systems, the kind of work you'd actually do at a top tech company. A portfolio with one project from each of these tiers is incredibly powerful.
And here's exactly how you can structure your time. This 12-week roadmap integrates learning with doing. You spend the first few weeks just shoring up your foundations. Then, for each new topic, Core ML, Gen AI, MLOps, you immediately apply what you've learned to a project from that ladder. By the end of this, you won't just have knowledge, you'll have a portfolio of deployed projects that prove you can do the work.
And there you have it, the complete roadmap. Don't fall into the trap of just endlessly watching tutorials. The real learning happens when you build. So your mission is simple. Pick a project, build it, and ship it. This field is defined by those who create. The only question is, what will you build first? Thanks for joining me for this breakdown.